Welcome to Engage Math, Lesson 22, Problem number 2, where we are simplifying rational expressions. Keep in mind, rational expressions are mathematical expressions where there tends to be an x in the denominator, at least before we simplify. So our goal here is really going to be to factor and then cancel. One common mistake that I just want to mention is you cannot cancel terms. 3x squared is a term because it's connected to that minus 75. This x squared is a term because it's connected to the minus 4x and the minus 5. The mistake that a lot of students make is they want to go, boom, x squared over x squared just cancels. You cannot do that because those are terms. And if you were to cancel them, then each of those terms would not have the opportunity to be connected with the other terms that are still remaining. So we have to factor and then cancel. If you look at 2a, the first step is our greatest common factor. So the greatest common factor in the numerator is 3, and that is always our first step in factoring. Take out that greatest common factor. So we have x squared minus 25. And then in the denominator, there is no greatest common factor. So if we think about a trinomial where the leading coefficient is just 1, all we have to do there is think of AM. We're adding to negative 4 and multiplying to negative 5. The two numbers that add to negative 4 and multiply to negative 5 are negative 5, or x minus 5, and x plus 1. Negative 5 and positive 1 multiply to negative 5, add to negative 4. Okay, but there's more we can do, because once we take out the greatest common factor, then we look again and we're like, oh, x squared minus 25 is the difference of two squares. So that's going to factor as x minus 5 and x plus 5. And so now we have the numerator and denominator all factored. And remember, we can cancel factors. So now the x minus 5 over the x minus 5 can cancel. And our final answer is going to be 3 times the quantity x plus 5 over x plus 1. We're done. All right, let's go to B. I think I'm going to zoom in a little bit. This one takes a little bit of work, so I want to make sure we have plenty of space for it. So we're going to once again take our first step, which is to take out the greatest common factor. So the greatest common factor in the numerator is 2. So I'm going to have 2 times 2n minus 3. Okay, now in the denominator, we have to remember how we factor trinomials that have a leading coefficient that's not 1. And one of the ways that we've taught it at Engage Math is something called splitting the middle term. So let's factor this denominator now by splitting the middle term. So the process is 2 times negative 21. You multiply a times c, which gives us a negative 42. Then we try, I'm going to move that over a little bit. So we have negative 42. And now we try to think of the two numbers that multiply to give us negative 42 and add to 11. So the two numbers that multiply to give us negative 42 and add to positive 11. So I'm going to give you a minute to think about that. All right, but it's not an easy one, I feel like, but we could try 6 and 7. That doesn't work. We can try 21 and 2. What makes this one so tough is that it's 14 and 3, a much tougher one to think about. So the only thing is the 3 needs to be negative because it has to multiply to a negative 42 and add to a positive 11. Okay, the reason this is called splitting the middle term is we are literally going to rewrite the trinomial with the middle term split. Now, a common question is, how do you know whether to write the 14 or the minus 3 first? And the answer is, it doesn't make a bit of difference. It will come out to be the same answer whether you put negative 3n first and then the 14n, or did it the way we did it here. Okay, so now what you do once you have split that middle term is you take the greatest common factor from the first two terms, which is 2n. So we have 2n times n plus 7. And then you take the greatest common factor from these two terms, which is minus 3. And we again have n plus 7. You know you've done it right when these two parentheses match. So now you have n plus 7 as the greatest common factor, and the factors, the coefficients on those two parentheses make up the other parentheses, the other quantity. So I can guarantee you that if you were to multiply this out, you would get back to 2n squared plus 11n minus 21. This is not the only way to factor a trinomial when the leading coefficient is not 1, but it's a good structured way. If you like this method, I would use it. Okay, so now I'm going to rewrite the denominator in the factors that it is. Makes no difference if I put the n plus 7 first or the 2n minus 3 first, but I just chose to do it this way, and 2n minus 3 cancels. So our final answer is going to be simply 2 over n plus 7. And we're done. Thanks for joining us today at Engage Math.